Okay, hello guys, welcome to my Minecraft Let's Play. Today we'll be looking at the five different types of chemical reactions in Minecraft, and we'll be going in order of combination, decomposition, single replacement, double replacement, and finally combustion. So let's just get right into it with combination reactions. So a famous combination reaction is sodium plus chlorine is sodium chloride, which is table salt. The way we write out these combination reactions is A plus X is AX, basically our coefficients, right? So sodium will be A, chlorine is X, and sodium chloride is AX. Now I've color coded these for us. So sodium is going to be these red crimson planks, chlorine is going to be these warped blue planks, and sodium chloride, or AX, will be these orange kind of acacia wood planks. And every time we have one of these reaction symbols, I'll make sure to put a diamond block or a block of redstone, whether we can tell if they're balanced or not. So let's get behind me. You'll see that I put the element blocks in using the Minecraft education system. So we have sodium plus chlorine becomes sodium chloride. And so basically single elements don't have a charge. So sodium and chlorine, they don't really have a charge by themselves, but when you mix them together, sodium chloride will have a charge, and we'll look at that later. What we need to look at is chlorine. Why is there two of them? Well, chlorine is a diatomic atom. Diatomic atoms mean that they can't be alone. And what I mean by this is that if we come over here, we can see the 7 diatomic atoms: hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. All of these must be in pairs of 2. They can never be alone. They always want to have a buddy-buddy, right? So these 7 elements, they don't want to be alone. So when we add them together, we have sodium plus 2 chlorine equals sodium chloride. Now, we're going to check the end result first, right? See if it's balanced. Plus 1 and minus 1, because sodium has a charge of plus 1, chlorine has a charge of minus 1. When they combine, they should balance, and these are balanced, which is great. But if we go back, we have 1 sodium, 2 chlorine. Well, wouldn't that give us 1 sodium and 2 chlorine, which gives us the charge of plus 1 minus 2. Now this is not balanced, and you can see that with the redstone block here. But how do we balance these? So let's look at the sodium, right? We'll come over here, and we do this by multiplying coefficients. And here in Minecraft, I can't make any subscripts, so the way that you'll differentiate coefficients from the amount of elements there are is based on whether it comes before or after an element. If it's before, it'll be a coefficient. If it's after, it'll be the amount of an element. So right here, if we look at the sign of the reaction in written form, we have Na plus Cl2 is NaCl. Now that's not the correct way to write it, but we'll just spread it all apart. We have Na plus Cl2 turns into NaCl. And our coefficients are going to be these oak wood planks here, or these oak wood signs here, separated by these birch wood signs. Now, coefficients will only always be separated by either plus signs or reaction symbols. So, if we go over here, how do we get more sodium? Well, it's pretty simple, right? We want 2 sodium to balance out the charges. So we'll just multiply the sodium by 2, we'll get 2 of them, and we write this as 2Na, or 2 sodium. Now that we have 2 sodium, it has a charge of plus 2, plus our chlorine, which has a charge of minus 2. That'll give us Cl2, and that should give us NaCl, which doesn't really make sense, because we have 2 NAs and 2 Cls, how do we only end up with 1 and 1 here? In reality, it gives us this. Well, how do we get this to this? Well, it's the same thing that we did for the sodium, right? Following this orange path, we have NaCl, we just multiply that all by 2, we get NaCl2, or 2 NaCl, sorry. And now we just go all the way back to our original equation and write the coefficients. I'll put them right on top of the elements. So we had Na, we had to multiply that by 2. Chlorine, we multiplied that by nothing, but we put 1 there just because there was no change. The diamond block here represents that it's balanced all the way. and we put a 2 on top of the NaCl because we also have to multiply that by 2. We write the coefficients down as 2, 1, 2, and the real way to write it is 2NaC plus Cl2 gives us 2NaCl. There you go, perfectly balanced. Sorry, the first one is explaining it a little longer because I really want to make sure that we have balancing equations completely down. Now next up over here, we have decomposition reactions. I bet you can guess what this is. AX equals A plus X. Basically, we are breaking an element down into its singular parts. So for this example, I've taken water and we're just going to be breaking it down into its singular parts. We have dihydrogen oxide, which is water breaking down into hydrogen and oxygen. And here I've color coded them, so water's blue, hydrogen's red, and oxygen is going to be orange. So everyone knows that water is H2O. That'll get break down into H2 and O2 because if you remember these diatomic atoms. Oh, I forgot to mention this, but these diatomic atoms are going to be marked with these blue torches. So anytime you see a blue torch, you're going to know it's a diatomic atom. That way we never get confused. We have the red redstone block here because it's not balanced. The O, there's only one on this side, and there's two on this side. Think of the diamond and redstone blocks as a great separator between the two. If there isn't enough on this side to match what is on this side, then it is not balanced. And I'll show you what this means. So first off, we need to get 2 of the O's, right? So we're going to multiply this entire thing by 2. So we have H2O, we're going to multiply this all by 2. It'll give us 4 H's and 2 O's. And we'll write this as 2H2O. And this is going to give us H2 and, oh, that's just a O2, but it'll give us O2 as well. This is still not balanced though, because now we have 4 hydrogens on this side, and only 2 on this side. So we're going to follow the hydrogens over here and just multiply the amount that we should get on this side by 2. By putting a coefficient of 2 in front of it, now we have 4. That'll give us 2 hydrogen, or 2H2, which will be 4 hydrogens. Now, looking at it in the grand scheme of things, this is how it's all pictured out, and you can really see how it's balanced now, right? 4 hydrogen on this side, 4 hydrogen on this side, 2 oxygen on this side, 2 oxygen on this side, completely balanced. I have these little diatomic atom markers. Even though this one has 2 of them, it's still a diatomic atom, can never be by itself. Now we just put it back into simpler terms here. We have the H2O, H2, O2. We put their coefficients on top, and we just finish the equation by writing 2H2O reacts to 2H2 plus O2. And that's deconstructing elements. Now with that out of the way, we'll just take a little hike up this mountain here. And really, I just wanted to explain like the whole multiplying coefficients thing, because it can get really tricky. We saw the diatomic atoms being broken down and being put back together. And here is where things get a little more trickier, but a little easier to understand at the same time. These are the single replacement reactions. And we write these down as AX plus Y equals AY plus X. Basically, you can think of it as like a Mr. Steal Your Girl kind of reaction. Where there's a happy, well, I don't know. There's a couple of elements and another one comes along. The other one that comes along usually hooks up with one of the couple, kind of like kicking the other one out to the curb. We'll see an example of this here, right? We have hydrochloric acid, which is the AX in this situation because it's hydrogen and chloride. And then we'll be adding zinc to it, which will be the Y. The zinc will replace the hydrogen, giving us zinc chloride and kicking out the hydrogen. Well, how do we know what's getting replaced? And why does something get replaced? Well, I'll show you if we come over here to the grand element tier tower, and I'll have to go into creative for this. We can see this large stack of elements. Well, what does this mean? It means that the elements towards the top will always replace the elements towards the bottom, and the way I like to think of this is like a kid at the store buying cereal. Kids at the store always want to buy the sugariest cereal. So right there at the top, we have the Captain Crunch, Lucky Charms, whatever sugar-inducing diabetes fever dream. And down here we have the Wheat Flakes. So the kid, the higher up on the tier list the element is, the kid will always want to pick that cereal. So in this case, right, we'll take hydrogen, right? Hydrogen's kind of like a midway, and zinc is kind of higher up on the tier list. Since zinc is higher up on the tier list, the kid is going to choose zinc because it is the more sugary cereal. That's exactly what happens down here. Whoops. That's exactly what's happening down here, right? But instead, the cereal is hydrochloric acid, the milk is actually the chlorine, and the cereal is the hydrogen. So, milk should not be chlorine in real life. If it is, you should probably see a doctor. But the hydrogen is the cereal that's getting replaced by the more sugary cereal, which is zinc. And the milk stays there, but the other cereal gets kicked out. Enough of me rambling. Now we can look at it through the element boxes. This should help us understand it a little bit better. We have zinc plus hydrogen chloride. And equals, sorry, my brain stopped working. We have zinc plus hydrochloric acid equals zinc chloride plus plus hydrogen. And I've already balanced this one for us. The only thing that I really need to do is multiply the hydrochloric acid by 2, because there's 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. Pretty basic stuff. We write this down as a 1, 2, 1, 1. And I hope that makes you understand single replacement reactions a little bit better. Excuse me, sir. The next one we're learning about is double replacement reactions. Now, double replacement reactions, this is where things start to get a little out of hand. But it's the most complex one, and it's really not even that complicated. AX plus BY equals AY plus BX. Kind of like wife swap, or like whatever. Swapping Pokemon cards, trading, whatever. I've given us an example here with iron 2 sulfide plus hydrochloric acid gives us hydrogen sulfide plus iron chloride. And what's happening here is that the iron is getting mixed with the chloride in this time, and the hydrogen is getting mixed with the sulfide. So basically what's going on is, well, let's just get to the element blocks so I can explain it with visuals. The iron sulfide and the hydrochloric acid swap their bonds pretty much. So the hydrogen now bonds with the sulfide, and the iron now bonds with the chlorine. So hydrogen will bond with sulfide, iron will bond with chlorine, and the way to balance this is you just put 2 hydrochloric acids, and this happens because of the charges that attract each other. Now let's just come up to my watchtower really quick. Oh, what do you know? Conveniently plays TNT on a hill. Well, better ignite it. Whoa, that was super epic. Ow. This totally reminds me of something. Like combustion, which happens to be our final chemical reaction. And the way that combustion works is that it'll release energy in the form of light and heat. That's how you know it's combustion, and it's going to be caused by a substance reacting with oxygen. So I have methane reacting with oxygen here, or carbon tetrahydride if you're a nerd. It's going to be reacting with oxygen, and one of the common outputs will be carbon dioxide and water. So in this case, we get it perfectly. It mixes up like that. And combustion will always have energy and heat released, so it's going to be explode pretty much. So think of bombs, anything else like fire, burning, explosions. So now that I've written them out in their element blocks, CH4 is methane. Whoops. CH4 is methane, O2 is oxygen, CO2 is carbon dioxide, and H2O is water. This isn't balanced though because there are way too many hydrogen on this side and way too little on this side. So, and there's only 2 oxygens on this side and there's 3 on this side. So, we'll just go over here, down here, and balance them. If you already know how to balance them, then that's great, but I'll just show it one more time. So we want there to be 2 oxygen on this side, so we multiply the entirety of water by 2. Now it'll give us 2 hydrogens and 2 oxygens. That'll match up with the hydrogens over here, but we only had 2 oxygens over here, so we need to multiply the amount of oxygens on this side by 2. And that's about it. You just need to balance the oxygens, and the whole equation pretty much balances itself. You write the coefficients as 1, 2, 1, 2, or 1, 2, 2, 1. Either way it works, it's fine. And if we come down here, we'll actually realize that, well, we've completed the entire thing. Just like that, you've learned all 5 reactions in Minecraft. You've learned combination, decomposition, single replacement, double replacement, and combustion ones. It's time to be happy, celebrate, question why you're playing Minecraft at 3 a.m., and hopefully you'll get a good grade on this. Bye now.